So this awesome thing happened to me today. I restarted my iPad, and apparently when you restart your iPad, your microphone for screen recording shuts off, and I recorded a video for you guys and thought it was on. So now I'm going to go into my camera roll here and just narrate what I was talking about in the video. So here we go. The purpose of creating this is to show you that you can create your own unit conversions using moles, compounds, atoms, and molar mass. And a lot of times you just need to try to figure out what the problem is asking you for and what you have available. So what we're going to be looking at here in just a little bit is a video that just shows you some of those options. So when you have 1 mole of water, you actually have access to quite a bit of information. You can tell how many compounds, what the molar mass is, how many atoms are contained, and you just need to unpack all of that. In this first example, we're just going to briefly discuss here, 1 mole of water will contain 6.022 times 10 to the 23rd compounds of water. And that works very beautifully for any mole to compound conversion. So you can literally be working with any compound in the world and it will contain the same number if you have 1 mole. Another thing that's very common is to calculate out the molar mass of a compound, which is covered in a different video and is a skill you should already have before watching this one. So 1 mole of water we've calculated in the past has a mass of 18.02 grams. This is very helpful when you are starting a problem where they're giving you moles and ask what the mass of the sample is, or they've given you the mass of the sample and are asking the question how many moles of water or how many moles of compound you have. Now, you can break this down even further and look at just a simple compound. So we could look at just the compound of water and look to see how many atoms total. Well, we know that we have 2 atoms of hydrogen and 1 atom of oxygen, so we can say we have 3 total atoms. If we're looking at specifically hydrogen atoms, we could also make the conversion factor that 1 compound of water has 2 atoms of hydrogen. All right, and last but not least, we can look at 1 compound of water contains 1 atom of oxygen. So you can see just from that really simple example that we have quite a bit of information that we can unpack just from being given 1 mole of a compound. The hardest part about stoichiometry, I feel like, is just getting comfortable with all of the conversion factors that you can use. And in future lessons, we'll be building upon that knowledge. Okay, so some basics here. So really basic problem. You're given the moles of a compound and asked what is the molar mass, what is the total mass of that sample. So we'll start off by writing 7.50 moles of water and putting that starting value over 1. We'll always start every single stoichiometry problem this way, and it actually makes it quite simple. The next thing I want us to think about is we know that in 1 mole of water, there's 18.02 grams of water. And so we can use that in our next setup. We're going to write moles of water, that 1 mole of water, on the bottom to cancel out the units of moles. Stoichiometry doesn't have to be hard. If you understand unit conversion canceling, it doesn't have to be hard. So this is where our moles of water will cancel out. And then on the top, I'm going to write that 18.02 grams of water. When you calculate that out, you're going to get a value of 135.15 grams. We're limited to the number of sig figs given in our original problem, which is 3. So we're going to round that out to 135 grams of water. And that should be our final answer for this problem. Okay, another common example of a problem that will be given is when we're given moles of a compound and asked to say how many compounds are in that sample. So again, we'll start by writing out that 1.85 moles of water over 1. And then look for a conversion factor that would allow us to convert to compounds. So we're fortunate in that we know that in 1 mole of water, there are 6.022 times 10 to the 23rd compounds. So we can use that conversion factor every time. Again, by placing the moles of water on the bottom of our conversion factor, it allows us to cancel out the units that we started off with. What we're left with is compounds of water. Again, when we are finalizing our answer, we can only have 3 sig figs in our answer. So while the calculator will give me 1.114 times 10 to the 24th compounds, I can only record 3 sig figs. So 1.11 times 10 to the 24th compounds of water. In this final example, we have 2 moles of water and we need to convert to atoms of hydrogen. Now, in our previous examples, we didn't give you a direct conversion to that, so we can actually just solve this problem using 2 conversions. So again, start by writing 2.00 moles of water over 1. Even when you're stuck on a problem and you're asking me for help, start by sending me this information that you've placed the information over 1. The next thing that we'll do here is go from moles of water to compounds of water. That is something that we can do directly. It wouldn't make sense to go from moles of water to grams of water because there's not a conversion that we've created that goes from grams of water to atoms of water. Again, that would be a multi-step process. So we'll write 1 mole of water has 6.022 times 10 to the 23rd compounds of water. This is a conversion factor that we can use because we know that 1 compound of water contains 2 atoms of hydrogen, and atoms of hydrogen is what we're looking for. Again, when we plug this into the calculator, it's going to give me a big number, 2.4088 times 10 to the 24th. I am only going to round my answer to the 3 sig figs that I am given from that 2.00 moles of water. So my final answer should be 2.41 times 10 to the 24th. And then atoms of hydrogen. Make sure you're always labeling out your final answer with the units that you are looking for.